code. And once you've done them, they are easy to maintain and grow. Apparently, difficult things often turn out not to be difficult after all. Ruby follows the principle of least surprise. It means things work the way you would expect them to, with very few special cases or exceptions, and that really does make a difference when you are programming. Introducing the group members. Ratnayaka RMTP, Atauda BAWM KGPB, and Gunawardena BGN, Kumarsinghe RW, Bandara CK. In the old days, the distinction between the languages was simple. They were either compiled like C or Fortran or interpreted like BASIC. Compiled languages gave you speed and low-level access. Interpreted languages were high-level but slower. Time changed and things aren't that simple anymore. Some language designers have taken to calling their creations scripting languages. By this, we guess they mean that their languages are interpreted and can be used to replace batch files and shell scripts, orchestrating the behavior of other programs and the underlying operating system. Perl, TCL, and Python have all been called scripting languages. When we come to Ruby, it is a dynamic, reflective, and general-purpose object-oriented programming language that combines syntax inspired by Perl with Smalltalk features. It is true programming language with strong theoretical roots and elegant, lightweight syntax. You could hack together immense of scripts with Ruby, but you probably won't. Instead, you will be more inclined to engineer a solution to produce a program that is easy to understand, simple to maintain, and a piece of cake to extend and reuse in the future. Although we have used Ruby for scripting jobs, most of the time we use it as a general-purpose programming language. We used to write GUI application and middle-tier server processors. We are using it to format large parts of this book. Others have used it for managing server machines and databases. Ruby is serving web pages, interfacing to databases, and generating dynamic contents. People are writing artificial intelligence and machine learning program in Ruby, and at least one person is using it to investigate natural evolution. Ruby is finding a home as a vehicle for exploratory mathematics, and people all over the world are using it is as a way of gluing together all their different applications. It is truly a great language for producing solutions in a wide variety of problem domains. Its creator, Yukiro Matsumoto, blend parts of his favorite language, Perl, Smalltalk, Eiffel, Ada, and Lisp, to form a new language that balances functional programming with imperative programming. Since its public release in 1995, Ruby has drawn devoted coders worldwide in 2006. Ruby achieved mass acceptance with active user groups formed in the world's major cities in Ruby-related conferences filled to capacity. Ruby Talk, the primary mailing list for discussion of the Ruby language, climbed to an average of 200 messages per day in 2006. It has dropped in recent years as the size of the community pushed discussion from the central list into many smaller groups. The TIBO Index, which measures the growth of programming language, ranks Ruby as number 9 among programming languages worldwide. Much of growth is attributed to the popularity of the software written in Ruby, particularly the Ruby on Rails web framework. Ruby is also totally free. Not only free of charge, but also free to use, copy, modify, and distribute. Initially, Matt's look at other languages to find out an ideal syntax. Recalling his research, he said, I wanted to script a language that was more powerful than Perl and more object-oriented than Python. In Ruby, everything is an object. Every bit of information and code can be given their own properties and actions. Object-oriented programming calls properties by the name instance variable, and actions are known as methods. Ruby's pure object-oriented approach is more commonly demonstrated by a bit of code which applies an action to a number. In many languages, numbers and other primitive types are not objects. Ruby follows the influence of Smalltalk language by giving methods an instance variable to all of its types. This eases one's use of Ruby, since rules applying to objects apply to all of Ruby. Ruby is seen as flexible language, since it allows its user to freely alter its parts. Essential parts of Ruby can be removed or redefined at will. Existing part can be added upon. Ruby tries not to restrict the coder. For example, addition is performed with the plus operator, but if you rather use the readable word plus, you could add such a method to Ruby built-in numeric class. Ruby's operations are syntactic sugar for methods. You can redefine them as well. Ruby's blocks are also seen as a source of great flexibility. A programmer can attach closure to any method, describing how that method should act. The closure is called a block that has become one of the most popular features for newcomers to Ruby from other imperative languages like PHP or Visual Basic. Blocks are inspired by functional languages. Matt said, in Ruby closure, I wanted to respect the Lisp culture. In the above code, the block is described inside do and end construct. The map method applies the block to the provided list of words. Many other methods in Ruby leave a hole open for a coder to write their own block to fill in the details of what the method should do. Unlike many object-oriented languages, Ruby features single inheritance only, one purpose, but Ruby knows the concept of modules, called categories in Objective-C. Modules are collections of methods. Classes can mix in a module and receive all its methods for free. For example, any class which implements each method can mix in innumerable module, which adds a pile of methods that use each for looping. Generally, Rubies see this as a much clearer way than multiple inheritance, which is complex and can be too restrictive. While Ruby often uses very limited punctuation and usually prefers English keywords, some punctuation is used to decorate Ruby. Ruby needs no variable declaration. It uses simple naming convention to denote the scope of the variable. These sigils enhance readability by allowing the programmer to easily identify the roles of each variable. It also becomes unnecessary to use try-some self prepended to every instance member. Ruby has a wealth of other features, among which are following. First, Ruby has exception handling feature like Java or Python to make it easy to handle errors. Ruby features a true mark and sweep grab collector for all Ruby objects. No need to maintain reference counts in extension libraries. As Matt says, this is better for your health. And third one, writing C extensions in Ruby is easier than in Perl or Python, with very elegant API for calling Ruby form. This includes call for embedding Ruby in software for use as a scripting language. as Swig interface is also available. The fourth, Ruby can load extension libraries dynamically if an operating system allows. But features, and the fifth one is Ruby features operating system independent threading. Thus, for all platforms on which Ruby runs, you also have multi-threading, regardless of if the operating system support it or not, even MS-DOS. And the sixth and the last one, the Ruby is highly portable. It is developed mostly on GNU Linux, but works on many types of Unix, Mac OS, Windows 95, 98, Millennium, NT, 2000 or XP, and also in DOS, BOS, or OS 2, etc. Introducing the structure and the execution of Ruby programs.